This is the fourth video in the series discussing the way in which one might approach a theory of everything. And if you may remember, I said that you don't need to progress very far with the history of the universe to be able to say that you can explain everything, because everything that's had to be done was done very early on. So what we've got to now is we've got as far as talking about the dimensions and the variables. I'm now going to talk about the laws, natural laws that regulate the way in which the network structure of nodes and separations between units of matter that form the nodes, the laws that regulate the way in which this is all held together. And the first law, I believe, is the quantum law, because it is very important that quantities need to be able to be evaluated in order to obtain certain effects. If you had a continuously variable mass or continuously variable space, then the quantity would not be as easy to determine, since there's no absolute value that you can compare. But if you have a quantum amount, a minimum amount of anything, then you can get an evaluation of an effect, such as mass, for example, determines the effect of force or energy or momentum. So as far as matter is concerned, remember I said that matter was the first variable that had to be created, and this is not a dimension in the same way as mass is a dimension. Matter is simply a multiplication factor, something that determines the magnitude of such variables as energy and force. And so that's the only thing about matter we need to worry about, is that it is in quantum amounts, and that involves there's a limit to the smallness and to the greatness of an amount, so that matter has a minimum amount and a maximum number of these quanta that can exist. A very large number that represents the total mass in the universe. I'm using the word matter kind of interchangeably, but later I will explain mass more as a property of matter. Matter itself is just simply an amount of substance. Now, as far as space is concerned, then space has a natural law, and that makes it the visible dimension, and that is that which is it's also in quantum amounts, because that's basic to any variable. The space between units of matter, quanta of matter, cannot be less than one. In other words, no two units of matter can occupy the same location. Location is not an absolute place, but it is. You can still have a location, even though you can't say where that is. So two units of matter cannot occupy the same space and the same location in space. And so space must have as a minimum of one quantum of separation. Any two bodies are always separated by one quantum of space. That makes space visible, because it reflects light and resists. When I touch this board, my hands cannot go through it because it is relatively solid, and each unit of matter in my hand cannot occupy the space of any unit of matter in that board. So that's what conserves space. Now, time also has a conservation law, and in this case it is momentum. In other words, when matter is traveling through time, it does so at a constant momentum, and this in fact is the only absolute movement that can take place, because movement in space is a change in the separation between bodies, and and the movement in time can diverge or converge and form a separation or change in a separation in space. So the time momentum is very important, and that is the property or the law that regulates time. Then we get to energy. Energy is represented by the total of all separations between units of matter, and what conserves energy is the fact that the energy between two bodies of matter is constant when the bodies are separate. So that the Earth and the Moon, for example, have a certain total energy between them, which is actually a total separation that includes the separation in time and the separation in space, and another third one that I referred to in the last video as the X dimension. The total energy, total separation represents the total energy, and that is constant. And because it's constant, then that is what determines the behavior of such phenomena as gravity. The X dimension does not have is the missing dimension that we don't seem to know about, but the total energy separation is greater than the sum of all the space dimensions and time dimension. There's energy in addition to, because space, you see, represents the potential energy between bodies. Time represents the energy that Einstein discovered with a special theory. Movement at any velocity, and this is true of any velocity, especially at higher velocities, involves a separation in time, and this increases the kinetic energy. But there is the kinetic energy due to movement in space, and that is represented by the missing dimension that I described before. And the value of the missing dimension actually is equal to the value of it is equal to the velocity in space, multiplied by a constant, which is actually the period of the system, and varies from system to system, and it varies within a system over a long period of time. The Moon's period now is 28 days per cycle, but this is always in seconds or days per radian. So, and that's about 1/6 of that, somewhere around 4 days or so, 4 or 5 days. And that's the period now, but it was maybe perhaps 8 or 10 times shorter than that when the Moon was first created. So that a higher velocity results, for the same energy, results for a shorter, when the Moon left the Earth, it was traveling much faster, about 10 times faster than it is now, about 2,000 miles an hour now, and between 20 and 25,000, I won't go into the exact amount now, when it was created. So the period was then shorter. So that's these are the these are the laws, and I now want to say something more about the variables that we have. The basic variables, I said, were energy, length is usually the way in which we denote the dimension. We often use R for the value, and then time. Now this is not an absolute time, it is the time difference between two bodies because they're moving. Now these are fundamental variables together with matter. Now matter, however, is not here a dimension. It is a dimensionless quantity representing the amount of matter, and it's a multiplication factor. And when you multiply the amount of matter, I'll use the word mass, they're close enough for most purposes. if you multiply the two masses of the two bodies, say the Earth and the Moon, you get a measure of the energy and force and momentum and such quantities that are affected by the amount of matter. Now from that, such variables as velocity actually is not a fundamental variable. It's a variable, you could say, that didn't exist until man needed to know about it, and we actually created the variable velocity, and this is the rate of change of the separation in space with time. And so it's essentially a slope, and slopes are not real variables. I don't mean that in the usual mathematical term. I mean they're not real in the sense that there really is no such thing as velocity. It is the ratio or the slope of separation in space as it changes with time. And then there's force too. Force is something else. Force is something that we have kind of created as an explanation for why bodies accelerate, but they actually accelerate for other reasons, as I've described in my theory of gravity. But force is the rate of change of energy with distance. So it is a slope again. And then you've got power. Power is I put the W there to avoid confusion with momentum. Power is the rate of change of energy with time, so there are the only three variables you can. Is that right? Well, you could have the inverse of those, but those are the three first level, if you like, secondary equations. And then, of course, you've got others like mass, which is the rate of change of energy with velocity squared, and is also equal to the rate of change of force with acceleration. Acceleration is the second derivative of velocity. And then you've got momentum, which we usually denote by P, is equal to mass times velocity. So we're now getting more and more complex equations, but none of these are really associated with the creation. They're what we brought in to help our physics to be more easily explained. Well, that's as far as I want to go right now. But the variation, the equations represent the laws of fundamental laws of physics, and it's these that determine how a network of mass and separations works. And in the next video will be interesting, because I'm going to discuss the way in which you get a solid body, a body that feels and looks solid and has mass or weight as a result of these forces. So that's the end of the fourth video. Thank you for watching.